So now we're going to look at a practical example of a quadratic equation in graphing that. We're given Abigail tossing a coin off a bridge with a height of 112 feet into a stream below with a velocity of 96 feet per second. So she's putting a lot of power into throwing this upward. And then eventually gravity is going to win. The height of the coin is modeled by the equation. H of t is equal to negative 16t squared plus 96t plus 112, where t is the time in seconds and h is the height in feet. So, what are we first going to do? We can look at this. We see we have a y-intercept at 0, 1, 12. So we can go over to our table and we're going to be able to write in 0, 1, 12. That simply comes from the fact that in a standard form, our c value is our y-intercept. All the other values, we're going to go get from our calculator, our table. We're going to type those into our calculator, which I've already done. And we're going to go to second graph to get our table. I see that I can start looking at those values there. I'm also going to scroll down a little bit on my calculator so that I get both the x and y values of 6 and 7 like they want me to. Okay? And I'm going to simply start by just plugging in values on the table. At negative 1, we get 0. At 1, we get 192, 240, and you can see exactly what I'm doing, just copying off the table here. You'll notice that I see some symmetry here, and all these values seem to be the same. That's no coincidence. So by looking at this, before I even start graphing, I know that I have a vertex at 3, 256. And I see my x-intercepts at 7, 0, and at negative 1, 0. Going to graph this, I'm looking at it, my x value or my function is t in time, or t is time in seconds. So I'm going to put time on my x-axis, put seconds there as my unit. I see my dependent variable is height in terms of feet. I put that on my y-axis. And now I'm just going to graph points. Now I notice that my x value and y value start at 0, 0. We'll talk about why that would be in a second. So I'm going to start at 0, 1, 12, which is going to be somewhere around there. 1, 192. Approximate it somewhere around here. 2, 240. Well, that's an easy point to graph. 3, 256. That's somewhere right around there. Again, I'm guesstimating where these are going to be. Now I notice that now, as I start going for 4, 5, 6, and 7, those points are all going to be at about the same height as they were for 1, 2, or 0, 1, and 2. So, looking at the point now for 2, 240, I see that this was also 240 here. So I'm going to go to 4, 240, and I notice that they match up. For 1, I was at 192. I'm also going to be at, where my x value is 5, I'm going to be at 192, so they should match up. They should be on the same y level, and they are. For 6, I'm going to be at 112. Should be at the same height as my y-intercept, because they're both 112. And then my 7, 0 is just an x-intercept. And again, this is a trajectory that I'd expect the coin to go in terms of its height over time. It's going to go up a little bit, then it's going to come down. The same force of gravity is working on it to slow it on the way up and to accelerate it on the way down. So we've graphed this. If we wanted to, we should also be able to look at a graph on our calculator. And if we set up our windows between 0 and 10 and 0 and 300, we could see that. I'll show you how to do that real quick. If you go to Window, our x-min, if we look at our x-axis goes from, our x-axis goes from 0 to 10, so my x-min is 0, my x-max is 10. My y-minimum is 0. And so I'm going to put 0 here, and my y-max, if I look at my y-axis, is 300. And I can now graph that, hitting graph, and you'll see that what my calculator shows me looks very much like what I just graphed. It's a nice confirmation. So now I'm going to be asked questions about my and y-intercept's my vertex, and all those kind of things. Well, if I go back to the last slide, again, I see that my x-intercepts have identified at negative 1, 0, and 7, 0. Now, what do they actually represent here? Well, let's think about it. Our x value is equal to time. Our y value is equal to height. And in both their cases, their height is 0. When the height is 0, I'm on the ground. So this is saying that at negative 1 seconds and 7 seconds, the coin is on the ground or has landed. Okay? Now that makes sense. After 7 seconds, at some point in time, the coin is going to be on the ground. But negative 1 seconds? Can I have negative time? Of course I can't. So while that is a mathematical answer, negative 1, 0 isn't a very practical answer. Because after all, the lowest x value I can have is a minimum time, which is 0 seconds. I can't go back in time. So really the only x-intercept that's really of importance to us is that at 7 seconds, the coin has landed. Now let's talk about our y-intercept. Our y-intercept, we know, is 0, 1, 12. Well, again, that means our time is equal to 0, and our height is equal to 112. When our time is 0, that's when I start throwing the coin. So this is saying that my starting height, or the starting height of the coin, is 112 feet. The height at which I threw my coin is 112 feet. My vertex. Our vertex, we found, was 3,265, if I remember correctly. 256, my apologies. So 3,256. Which means my x is equal to 3, and the value on its time, so it's 3 seconds. My y value is 256 feet. My vertex is my maximum height as well. So what my vertex tells me is, at 3 seconds, the coin reaches its maximum height, of 256 feet. And all I did was I figured that out by understanding that 3 is my x value, and x represents time. 256 represents my y value, and y represents height in this problem. And the vertex, since it opens downward, it's my max height. What is an appropriate domain? So we're looking at x values, which is our time, and specifically the time the coin is in flight. Well, our minimum time can be 0. I can't go back in time. I can actually reach 0 seconds, so that obviously is going to be a bracket. At 7 seconds, the coin lands. And I can't go any further. At that point, this function no longer represents the height of the coin. So I can go from 0 to 7 seconds. After 7 seconds, the equation for my coin is y equals 0. Finally, finishing the appropriate range. My appropriate range is y values, which represents height. And it's going to be my min and my maximum height. Well, my minimum height is when it's on the ground, which is 0. And its maximum height is from the vertex of 256 feet. So at any given time, my coin is between 256 feet. At any given time, between 0 and 7 seconds, my coin is in flight. That finishes today's lesson. Please finish your 8.4 homework assignment, or at least start on it at this point, and be prepared for a potential little bit of a quiz on that tomorrow. And we'll also look at the situations, again, when we have no x-intercepts.